math homework doers. We're looking here at where are we at? 1.7 still, number 2. And we did a little throwback here to lesson 6 to help you out. We were struggling with the area of a triangle. So we got triangle A here. Let's analyze triangle A just a little bit. All right. Triangle A has a base length from bottom left to right is 3. And it has a height that is actually also 3, because that's how we do height on triangles. It's a perpendicular height from the base. So we know that 3 is the base, 3 is the height. And what a lot of you are wanting to do when trying to find the area of this shape is just do 3 times 3 and say the area is 9. Well, 1, 2, not even a full second. I'm not going to be able to fit 9 full squares inside of that triangle. There's just no way. So you're forgetting to do one thing, and that is to take and find half of that product. So you do 3 times 3 to find the area of a triangle, but you also got to cut that in half. So this turns out to be 4.5 square units of area. I can fit 4.5 of those blocks inside of this shape. Okay, and what Lynn's gone and done is he's making a scale copy of this triangle, and he's making it bigger because he's going from 4.5 square units to 72. So he's drawing a larger version, okay, a scale copy. So it looks the same, even though mine's not a great version. It looks the same, but instead of having 70 or 40.5 square units, it has 72. So he's multiplied by something to make it larger. All right. So let's look at the questions. How many times larger is the area of the scale copy compared to that of the original triangle A? So we need to take 72 and divide it by 4.5 is what we need to do to find out how many times bigger it is. So some simple multiplication. You can use calculators on this if you want to. You can do some long division like I've set up right here. But if you do this correctly, it does turn out to be 16 when divided. So they're essentially saying that this is 16 times larger than the one that it was before. And that really helps us out a lot, because not only do we answer part A, but it helps us with the scale factor, because we learned something about the scale factor. Whenever we scale this up to a larger size and the area grows by a certain multiplication, that's not technically the scale factor. We learned that the scale factor has to get squared to be able to show how many times the area is going to grow. So what number could we multiply by itself and get 16? That's really the question here. So what are we multiplying these numbers by to get the side lengths, not the area? And it has to be a number that is multiplied by itself to give us 16. And that number is 4. Okay, this is basic squared number here. 4 times 4 is 16. It's not 5 times 5, too big. 3 times 3 is too small. So they are scaling it by 4. So from 3 times 4, that tells me that this is 12 in length. And the height would get scaled by the same number, and it was 3, so times 4, that means that it's also a 12 by 12 triangle. And that makes sense, because 12 times 12 cut in half is 72, so even the areas match when you find them that way. So what's the scale factor? 4. What is the length of the bottom side? I just answered that too. That's 12, because we scaled the bottom side by 4 to get there, and that's going to be 12. So that is homework problem number 2 from 1.7 practice problems.